Hello and welcome to this video series on the Common Emitter Transistor Amplifier. In this video we're going to go over some high-level concepts so we understand how we can design one. In this video we're going to feature the Npn transistor, which has a collector, base, and emitter. The transistor is a three-terminal device. Its input connects to the base of the transistor, and the output is taken from the collector. The goal of the amplifier is to provide gain to the circuit. Gain is the ratio of the output to the input. In this series, we're going to design an amplifier with a gain of 10. Let's take a look at an actual measured waveform from a common emitter amplifier. Here we can see the input in purple and the output in yellow. The gain of this amplifier is approximately 10. Here's a frequency sweep of the input. Notice we don't see distortion and the output wave retains its amplitude. There are two main concepts critical in the design of the common emitter amplifier. One is to keep the transistor on, and two is to keep the transistor linear. Let's first consider keeping the transistor on. We need to focus on the base emitter voltage of the transistor. In order to have the transistor on, we need to bias the transistor. And what that means is we need to overcome the base emitter voltage. We do this with the voltage across R2. This voltage must be greater than the base emitter voltage, which is typically 650 to 700 millivolts. Now let's focus on the second design objective of the common emitter amplifier. That's going to be keeping the transistor linear. What we're ultimately trying to do is create the output that is just simply a larger version of the input. So the equation is the voltage in times the gain equals the output. The gain should be a constant, so it shouldn't modify the input and change its shape or pattern. We simply just want a copy that's larger than the input. In summary, we can use a transistor to amplify an input signal, and we measure the amount of amplification by the gain, which is the ratio of the output to the input. Thank you for watching this video, and I hope you learn more about the transistor amplifier. Stay tuned for more content, and we'll see how we can transform the schematic to the breadboard, and then take some real measurements and look at more design considerations and move us away from these two ideal design considerations of keeping the transistor on and keeping it linear, and see how we can set practical ranges and select the values that enables us to amplify and measure our signals of interest. Thanks again, and I hope you have a great day.